So I want to show you some progress we're making here on the engine. As you know, I got the fuel injection components and ECU and all that kind of stuff, so I'm just test mounting a couple of the injectors, and there's some spacers that need to go in here that I've got sitting over there. Fuel pressure regulator, which will mount somewhere over here, so that I've got a Y in the line that comes in feeding these two rails, and then it'll come here, and then the return line comes out the bottom. So it's AN 6 fittings feeding in, and then an AN 4 line running back. This is one of the two Holley direct like distributorless and ignition system components, the coils. What else? Yeah, I'm fooling around with sensors. So there's a bunch of sensors somewhere. Anyway, sitting right over here, and so there's a coolant sensor that goes here, and then I've got an oil pressure sensor here, and this is 10mm fine threads, and I can only get 1/8" NPT, so I've got an adapter here for this 100 psi fuel pressure. Sorry, I'm using one for fuel pressure and one for oil pressure, and then there's oil temperature going in here. So both of those monitored. As I explained previously, I've got a fuel rail. Sorry, I've got a log plenum that runs along here, and what I'm going to do is these unscrew, and so I'm going to mount an air box and fabricate an aluminum air box, and on the back of the air box I'm going to mount the plenum and some of the sensors and stuff and the wiring. Oh, by the way, this is from NOS Wizards. This is their Quadranoid solenoid with 4 distribution ports, and inside the ports you thread the jets. So I can thread in 15, 20, or 25 horsepower per cylinder nitrous jets, which is what I've got set up. And there's an integrated filter built into this. These things are the best solenoids on the market. They're made in the UK, and they're basically bulletproof, and they're meant to be pulse width modulated, so you can run a progressive nitrous system without having to rebuild them all the time, which is like a really, really key thing. And they run plastic lines rather than the braided lines. Very, very small diameter hole. This is the low pressure lines that run from the solenoid to the injectors, and then this is the high pressure line that runs to the tank. So this will, even with this tiny little hole here, this will support 150 horsepower. The idea behind these smaller lines is less volume, less cross-sectional area, and less volume in the line, so you don't need to purge. The system runs much better than having all that volume to push through all those lines, and you actually waste a lot of nitrous. I'm going to use something called an argon assisted nitrous system, where the argon is feeding. There's an argon tank that feeds pressure into the nitrous tank, so that you don't use a bottle heater, and you end up with much more consistent pressure through the system, so it's easier to tune and you don't need to worry about it warming up the bottle before you use it. These are the injectors, and these injectors are beautiful. They're very thin, and they're going to go, I've screwed in these little ports. These are going to feed the log plenum. They're right after the throttle body, and then these little nitrous lines I'm going to drill in a little plate here. I'm going to drill right in the base, and they will stick up. Like if you look at the sideways at the throttle body, they'll stick up just inside the throttle body and spray the nitrous right into the engine that way. So that's gonna be pretty cool. Next thing you'll notice, I've mounted the water pump, test mounted it, and I've got my Serpentine system and my racing alternator set up here, and then I've got some lines set up here. Now let's talk about the Serpentine system first. So I'm changing this pulley on the alternator, which is for a stock ratio, 2:1. So the engine turns, that turns twice. The engine turns twice for once for the alternator. Sorry, the other way around. So the maximum speed on these things is just over 20,000 RPM. So I'd overspin it at 8,500 RPM. So I've got a custom machine pulley here that is 2.5 to 1. So it's going to keep the revs on the alternator down a bit. So my charging current will be a little lower, but my idle speed is going to be 950 approximately rather than say 700. So it's all going to work out nicely. I should still get about 22, 23 amps of charging current from that little racing alternator, which is about 65, 70 amps when it's spinning fast. And then we've got custom water pump pulley, and then the Fluidamper custom crank pulley, which will get rid of the engine vibrations as well as you know, just look pretty. So, and then we've got the Serpentine belt system. There's the Serpentine belt over there. So that's that part of it. So that's going to be very, very nice looking. It's also necessary for me to mount all this stuff with these custom billet brackets lower than stock to clear this. Now I'll show you an interference fit that I found, which is making me unhappy, but I knew this was going to happen. So this is the ABF ABA motor front water pump water, like you go. This is the return line. So air water gets pumped from the radiator through the water pump into the block, and then it comes out the side of the block over there and returns down to these connections here, and it also comes out here and straight to the top of the radiator, and it's got an interference fit with my my nitrous injector line and this vacuum port that I've installed. So I'm going to have to take this and make an aluminum, like fabricate an aluminum version that'll fit this profile here, probably come down at an angle, connect into here and out. And then this is the breather for the crankcase ventilation system. I'll have to feed that out some way as well. So got to figure out all the wiring of the vacuum and nitrous lines and the water lines in this area. And I've been trying to find a way to run an electric water pump, and it looks like I'm gonna have to bail on that idea. I'm not dead sure, but problem with an electric water pump is I take the impeller out of the water pump here. So take this apart, remove the impeller, and then drive electrically water into the fitting that goes here. And that would circulate through the engine, but it wouldn't run properly through the heater core or this water to oil intercooler here. And this is nice because it warms up the oil faster than the oil would warm up on its own, so it's just better for engine longevity. But everything's really cramped in this area here. Let me zoom out a bit. We're just way too tight. This area of the engine is like super busy. Even on the stock engine, and with the individual throttle bodies and all the other stuff I'm doing here, there's just too much going on in this area, and I don't think I have the ability, easily at least, to plumb in an additional water pump here just to run the heater core and this, as well as the other electric water pump and all the fittings and stuff. So I think I may just say, screw it, I'm going to lose 3 to 5 horsepower by running a standard mechanical pump. But I just end up with a more reliable, simpler layout of the engine. So I think what's going to happen is I'm going to build the engine this way, and if I'm unhappy with the amount of power if I'm a fanatic enough and I'm unhappy, I can always take it apart and redo it later. Leave that for now. So that's it. That's my engine update for now.